Welcome back to my course Aspects of Biochemical Engineering. In the last two lectures, I tried to discuss the air sterilization process. Now, this particular lecture and coming lecture, I am going to discuss the medium sterilization, because the medium sterilization appears to be the one very important aspects as per biochemical industry is concerned, because the purpose let me repeat it again, that purpose of the sterilization is to allow your desired organism to grow, and that is why you want to make the environment totally free from other organisms, so that your desired organism can grow. Now, here if you look at that what is the purpose of the medium sterilization? Medium sterilization is one of the most one of the first and most critical unit operation required for successful fermentation. The objective is to prevent the growth of undesired microorganisms during the course of a fermentation and bioconversion, enzyme catalyzed reaction and medium storage. So, you know that this is the main purpose. As I told you, the medium sterilization can be achieved by two means. One is filtration, and there is the thermal treatment for discussion. Now, filtration we have shown previously. In the filtration, what we do, we physically remove the microorganism. What I told, that suppose you have fiber like this. In between the fiber, when you suppose you have, this is filter, I told you this is filter and this is the supporting material. So, when you pass your air like this, so this is the fiber, and in between the fiber your organism will be entrapped. Am I right? And in case of another type of, this is fiber, in case of membrane, we have pore size. On the basis of that, we will not allow the bigger size particle to enter into the system. This is how we can do that. And thermal treatment we heat it, so that your organisms are killed. So, I told you that high temperature the protein undergo denaturation process, and due to denaturation of the denaturation of the protein, the biochemical activities of the organism will be stopped and your organism will be killed. That okay. Now, now in case of media, that since the media is a good conductor of heat, that we consider the heat is the best media for the sterilization of the medium, but in not like air sterilization, because air sterilization I mentioned the air is a non-conductor of heat. So, that is why we consider the filtration technique for air sterilization. Now, in case of medium sterilization, since it is aqueous base, water base, and water is good conductor of heat, so we go for thermal sterilization process. Now, sterilization of filter. Now, the sterilization is filtered. We sometimes we used to do, because let me tell you the why we don't use this filtration technique for medium sterilization, because again it depends on the type of fermentation you are looking for. Because why? Because suppose I use some kind of membrane filter. Am I right? Now, in case of membrane filter, this is the membrane, and you want to pass your material bond end and take out the material from here from other end. Now, suppose size of the bacteria is 0.5 to 2 microns. Am I right? So, what is the pore size of the membrane? It should be less than 0.5 micron, less than 0.5 microns. Am I right? So, now if you pass air that media through this membrane, there will be tremendous pressure drop across the membrane, and due to the tremendous pressure drop, your operational cost of the process increase very high. So, your operational, and not only that, due to high pressure difference, what will happen, that the life of the filter, that membrane also is a very important factor, because life of the membrane will be reduced. Am I right? Now, let me discuss about the how the sterilization process is effective by filtration. Filtration process does not destroy, but remove the microorganism. It is used both for the clarification and sterilization of the liquid, as it is capable of preventing the passage of both viable and non-viable particles. Sterilized solution may be damaged or denatured by high temperature or chemical agent. This is one of the reason where we can consider that filtration by sterilization by filtration in case of medium sterilization process, and we have come across two type of bioproducts we have in the market. One is high value products, another is the low value products. High value products means per unit cost of the product is very high. So, when we handle the high value products, that means your volume of the liquid, volume of the your product, that will be very less. There we can think for this sterilization through this filtration process. Now, the mechanism of filtration by sieving, adsorption and trapping within the matrix of the filter material. The pore size of the filtering bacteria, yeast and fungi is in the range of 0.22 to 0.45 microns. Now, let us see what is the advantage of using this thermal sterilization process. Now, thermal sterilization, as I told you that in case of thermal sterilization process, because why we use, because water is good conductor of heat, that is one of the reason, and when you heat it, your bacteria or organism, that protein present inside the organism that undergo denaturation, so that the activity of the enzyme will be lost and organism will lose their biochemical characteristics. Now, this can be done in two ways by using one is by using dry heat and moisture heat. Dry heat means it employs the higher temperature in the range of 160 to 180 degree centigrade and require the exposure time 2 hours depending upon the that temperature employment. But in case of moist heat is quite effective. This is 121 to 140 degree centigrade, and steam under pressure is used to generate higher temperature needed for sterilization. Now, because obviously the moist heat is much more effective as compared to dry heat, that I told you that, and dry heat means by using hot air we do that, and moist heat by the help of steam we do that. Now, there is a term called thermal death time. However, the thermal death time means the shortest time required to kill the microorganism in a sample at a specific temperature under defined conditions. This is the how to call it thermal death time. And decimal death reduction time is what? It is the time required to kill that 90% of the organisms in a sample at a specific temperature. So, two type of time we consider. One is thermal death time, that to kill the microorganism how much time is required. Another is the decimal reduction time, to reduce the organism to 1/10. That is why we call it decimal reduction time. Now, let us see the equation, the kinetics of thermal death rate of microorganism. Now, dN by dt, this is the first order kinetics. Kd is the thermal death rate constant, and N is the number of viable organisms. This is the how we can write it. Now, this we can express easily in this form, that no, this is dln N equal to Kd into dt. Am I right? So, this we can write in this form. If you write this is minus, so we can write in this form. Then from this equation we can come this equation, the ln, I told you this is the ln ln t by n0 k into dt, and decimal reduction time is what, that I told you that nt whatever is there, it should be, this will be what, n0 by 10 decimal reduction time, 1/10 of that. So, you know that so this is exactly that we can n by n0, that will be 1/10, that will be equal to that e to the power k1 e to the power kd into d, that d is the decimal reduction time. So, this will be equal to 2.303 by kd. So, here I want to point out that when decimal reduction time is inversely proportional to kd, that means as your temperature increases, suppose you have this temperature and this is kd value, as you increase the temperature you will find the kd value also increases. Now, as your kd value increases, then thermal decimal reduction time will reduce significantly, and this is the advantage of this is the advantage that we use in case of continuous sterilization process. I shall explain you later. Now, this is the plot that we have. This is exactly that I was discussing about that minus dn by dt equal to kd into n. Am I right? So, this is the straight line plot. If you write like this, dn by n equal to kd into dt. Now, if you plot, this is what, this is equal to d ln n minus this is equal to the kd into dt. So, this is negative. So, this will be negative plot here. If you take it out, it will negative. So, it is negative plot. So, it will be straight line. Basically, this is y equal to mx. So, basically, this will be straight line, and slope slope will give you the value of kd. This is kd is the decimal reduction time. Now, if you have normal plot nt by n0, then you will be having this kind of plot. So, if you look at the kinetics description, makes two prediction which contradicts each other at a finite time, as at infinite time, as infinite time increase is required to achieve the sterile condition, and after a certain time there will be less than one viable organism remaining. That is exactly I was trying to point out, that to get 100% sterility is very difficult to achieve. So, what we do, one, how much organism we allow, how with on the basis of how much organism input, that we shall have to do. So, infinite infinite time is required to achieve the sterile conditions. The value of nt less than one organism is considered in terms of probability of the organism of surviving of a treatment. So, how much organism will be survive out of how much organism input, that we consider that determine the degree of sterility. Now, thermal, this is very interesting. If you look at that thermal, we have already shown, this is log graph paper. You can see the 10 to the 5, 10 to the power 10 to the minus. This is log, this is log, semi-log graph paper, not this is semi-log. So, this is the time. So, we find that as the temperature increases like this, so this is 54, this is 56, 58, 50, 60. Now, as you tell, this slope will be becoming steeper and steeper, and this slope will be what? This slope we have already found out, this is kd. That means kd value increases as the temperature increases. Am I right? And if you normal plot will be this is kind of pattern we will get. Now, this is very interesting thing, that if you look at here at 100 degrees, if you have 100 degrees sterilization temperature, kd value or the thermal death rate constant value, k is the thermal death rate constant, the holding time is 1730 minutes. That means this is the sterilization time that is required. Now 110 degree centigrade, it is required 164 degrees centigrade. This is by using the organism Bacillus thermophilus. Now why we consider Bacillus thermophilus? Because this is the heat stable organism. That is why we have taken into consideration. The 120 degree centigrade, it is 17 minutes, 130 degree centigrade, it is 2 minutes, 140 degree centigrade 0.225, and 150 degrees 0.004. Now what does this signify? It signifies that as your temperature increases, your time drastically reduces, and that is very important. Why it is important? Because if you look at that deactivation temperature of the vitamins or amino acids, so it is usually lie in between what, 80 to 90 kilojoules per mole. Am I right? Now if you look at the microorganism, it is very high. It is about 300 something, because or close to 300 kilojoules. So even what I want to mean, that even you see 100 degree centigrade means you heat it for at a very small temperature. So then you have to keep it for longer period of time. So if you keep it for longer period of time, that your Kd, the deactivation energy that is required for the deactivation of the vitamin and amino acid, that already you supply. So that degradation of the medium quality will decrease to a great extent. But if you increase high temperature, then you are using very short time, and naturally that you are holding the media for a short period of time, and so loss of the nutrient will be very less. That is why in the industry we use the technique what we call HTHT. HTHT means high temperature short time. This is largely used in the media, because if you expose, because now I can give the example. Suppose in a media you have some nutrients and concentration is there. Let us assume the volume of the media is V, and the quantity of the ingredients that you are talking about, let us assume the amino acid concentration maybe you C. So that, so this will like this. Obviously it may this may depends on temperature. This is how the BC quality that decrease with respect to temperature. So you can easily find out. Now suppose this is 100 degree centigrade, and this is maybe 140 degree centigrade, but it might be maybe this is maybe for 100 minutes. This is might be for 20 minutes. But that if you go like this, that that even at lower value, you will find that what I want to say, want to tell you that if you go for higher temperature, then your exposure time will be very less. That is drastically reduced, and so the quality of the vitamin will be remain like this. So what I can tell, this is one plot, this is another plot. So so we can easily find out that the quality, this is V1, this is, let us V1 into N, and this is V2 into N. So this is the smaller volume and this is the bigger volume. So if this is the plot that you have. Now in case of batch sterilization process, if as you increase to the that lab scale to the commercial scale, you have to handle huge amount of liquid. Naturally, you have the time requirement for the sterilization will be very high as compared to. So this is one of the bottleneck, and second bottleneck is the time of this exposure time. And due to these two reasons, that we don't use this in the industry, we don't use the batch sterilization process for the sterilizing the media. So, what we use the continuous sterilization. Now, batch sterilization I shall discuss little bit in details, that in the batch sterilization what is happening, that the liquid media is mostly is commonly sterilized in the batch vessel where it will be used, and the heated the sterilization temperature, because what I want to mean here, that you see that it add up 10 to 20% of the liquid volume, because that is that condensate, because this is very important. When steam is used, the condensate added, because the 10 to 20% of the liquid, thus the dilution will be made accordingly. The time required to achieve desired level of destruction is called the holding time. So, this is the major problem that we have. I shall discuss more in details here, and this is the device through which we can do the batch sterilization. One is steam, and the electrical heating, and the heating with steam, isolated heating source, and cooling with the coolant, non-thermal coolant. That with different type of system we can use. Now, this is the major problem that we have. Suppose this is a liquid, am I right? This is a liquid that present in the reactor, and we want to heat it. Now, what we do that so suppose we can do it in two ways. We can pass hot water here and increase the temperature. This is the kind of standard we have, or we can inject the steam directly. We can inject them, increase the temperature. Now, whenever we do that, first your temperature will rise like this. Then you have to hold this temperature, because our sterilization temperature is 121 degrees centigrade. Am I right? And then you hold for some time in decrease. Now, during heating the process, some organism will be killed. During the holding the process, most of the organism will be killed, and cooling process also some organism will kill. So, total sterility not only depends on the holding section, it depends on the heating section as well as in the cooling section. Now, this is apart from the contamination, the heat of sterilization destroys the nutrient in the media. High temperature short time techniques is used, so that the time exposure is drastically reduced. The holding time, what is the speciality of that? In the holding time, you are maintaining the temperature constant. So, your Kd value is constant. So, we can write the time required holding time is N1 to Nt, N2, that is reduced, is divided by, we can find out what is the holding time required here. Now, Kd can be evaluated like this, that this is the Arrhenius equation, that we know Kd equal to A into A is the Arrhenius constant, and Ed is the deactivation energy required, Rd is the gas constant, is the absolute temperature. So, this can be correlated like this. This is equal to dN by dt equal to Kd into N. Am I right? So, if it is so, we can derive this equation from this equation 4. Now, finally, we have this equation, that is ln 2 by ln f, that is final. This is the equation we will get. The T2 is the time at the end of the holding, and Tf is the end of cooling. So, the equation 4 and 5 cannot be integrated till the exact time of profile during the heating and cooling period is known. So, that is exactly I am saying, that the amount of organism killed during heating, amount of organism during cooling, and total sterility depends on the summation of this plus this plus this. So, it will be like this. This is for heating, this is a total removal of the organism is this is heating, then this is cooling, and plus this is holding. So, all this if you add together, we will get that. Now, in case of batch process, we have different devices we have already shown. One is steam spurging, electrical heating, heating with steam, cooling with coolant. So, this is different equation we can use just to calculate. Now, longer that what is the major drawback? The longer holding time is required to treat the solid phase substrate and media containing the particles. During the scale up, the longer treatment time are added to achieve the same sterilization I just now I mentioned, resulting the same holding temperature. Sustain the elevated temperature during the heating and cooling damage the vitamin, proteins and sugar, which turn reduce the quality of the nutrient, and large amount of volume is used to make the batch process tedious and energy intensive. So, this is the couple of reasons why the batch sterilization process at all is not that they are not followed in the industry. In the industry, we follow the continuous sterilization process. One of the major and technique, as I told you, that we use that HTST technique, and the major important factor is the steam consumption is reduced to 20 to 25%, and the total time required for the sterilization of the continuous system is 2 to 3 hours as compared to 5 to 6 hours in case of batch sterilization. As we know that industry, time is very important, because every time they count money, because how much money is spent. So, since the time required for the phase sterilization process is more, so money involvement also will be more. Now, there are two type of continuous sterilization process. One is direct steam injection, another is the plate heat exchanger. Let me explain. Now, direct steam injection, because how it is done, suppose this is the raw media, am I right? It is coming in this direction, and the steam is coming in this direction. Steam is coming this way, and this is the mixing thing. And then this is called holding section. This is the holding, and this is insulated. This pipe is totally insulated, so that no heat loss take place. So, the main advantage of this process, that raw media and steam, they instantaneously they mix together and raise the temperature. Suppose your sterilization temperature is 140, because in industry we use the 140 degree centigrade, because we keep it very short time, not like our lab 121 degree centigrade. So, this is the rapid heat up of the media that take place, am I right? Then here we have expansion valve, through which we put it in the flash, just you throw it out, then the flash cooling will take place, and here we will get the sterilized media, and here at the top the vapor will go out. So, you might have seen that lot of industry, they are discharging lot of white fumes, and white fumes are nothing but it is vapor that is coming out from the from the industry. And this approach is particularly effective with media that tend to foul the heat exchanger, and disadvantage is that this approach is the dilution of the media with condensed steam and difficult to control pressure and temperature due to variation of viscosity. Let me explain that, because if you look at here, that what you are doing, you are mixing media and steam, am I right? As soon as you mix together, the steam will undergo condensation. As soon as the steam undergo condensation, your media will be diluted, and viscosity will be changed, density will be changed. As we know, the flow characteristics of the fluid depends on the viscosity and the density. So, as they are changing, so what will happen? The flow characteristics will change, and temperature control will be a problem, the operational problem we have. This is the major problem we have for operating this direct steam injection technique. Now, this is if you have temperature time diagram of this particular system is like this. The temperature instantaneously increases 140 degree centigrade and hold it, and then your flash cooling, to 80 degree centigrade. then it slowly is cooled down to 37 degrees centigrade. Now, plate heat exchanger, that is mostly used by the industry. This is what is this? This is, they have different heat exchanger. This is suppose this is 1, this is 2, this is 3. Am I right? 3 exchanger they use. Now, here this 2 they call it economizer. Why they call it economizer? Because what they do that here here you are preheating the media. How you are preheating the media? The media after holding section, when the media is going out, that heat we are using for preheating the media, so that we can save lot of energy, and that is why we call it economizer. And then we may raise the temperature at as high as 80 degrees centigrade. Then we pass through this, and here might be 140 degrees centigrade. Then we keep it in the holding section for whatever time is required for your sterilization. Here we use steam for heating purpose, and then we can pass it here. Here we might be having 80 degrees centigrade, or more than that. So here you will pass. This is a chiller. This is called chiller. Chiller means we pass cold water to reduce the temperature of the. This is how this is operated, and temperature time diagram is like this. Temperature increases like this, then we hold it, and then we cool it like this. The economy, this economizes the steam requirement of heating and cooling the sterilized media. This process is effective with media containing the suspended cell. Fouling of the heat exchanger surface, leaks around the heat exchanger gasket, and still fewer drawbacks of the process. The major drawbacks is the, suppose if you look at this heat exchanger, this is usually the parallel plate heat exchanger. It looks like this. This is the parallel plate heat exchanger. So one plate we are passing hot media, another plate we are passing the your media. So it may so happen the hot surface, the media comprises a lot of organic material, lot of dissolved solid that may deposited on the surface of the that wall, and that scale, when there is a scale formation of the wall, that is less conductor of heat, naturally your heat requirement will be more. That is undesirable. That is the major problem. And another is the leak. This plate and plate, they bounce together with the help of some gasket, and since how you maintain the 140 degrees centigrade by increasing the steam pressure at very high. So naturally that there is every possibility that there is a kind of leakage that take place inside in the gasket. So that you have to open it again rectify this problem. Now we find that in the industry that up to 140 degrees centigrade we can easily use for the sterilization of the media. Now flow characteristics of the media plays very important role, because if you know that we have this is the plug flow, this is the turbulent flow, this is the laminar flow. Now if you have this laminar flow, you can see the velocity gradient across the cross section of the tube. Now if you take this velocity at the middle of the tube, then it is very high. This is U max. Am I right? Naturally, then on the basis of that, if you take if you consider that time required for the sterilization, here the media will be underheated. Now here, if you take this time, here time for for determining the length of that sterilizer, then you will find that your media here, this will be overheated. Now overheating and underheating, two problem that we have due to the flow characteristics of the fluid. So usually we prefer that plug flow is the ideal flow, very difficult to achieve, but usually we use the turbulent flow, so that temperature gradient across the cross section of the tube should be minimum. The residence of the media in the sterilization depends on the type of fluid flow to assure the adequate sterilization. flow is somewhat between the viscous and fully turbulent flow, such that the average velocity 0.5 to 0.82 times the maximum velocity. In order to maximize the overheating of the media, it is desirable to approach closely fully turbulent flow, and this occurs the NRE value at least 2.5 into 10 to the power 3, preferably above 2 into 10 to the power 4. So, this is the desirable characteristics that we have of the fluid for the proper sterilization of the media. Now, then other for finding out that that sterilization temperature or design the sterilizer, we come across different other parameters like Piclet number, which is equal to UL dz, and dz is the axial dispersion coefficient, L is the length of the sterilization, and U is the velocity of the fluid. And Reynolds number we know du rho by mu. And this is how we can find out that Damkohler number. This is equal to Kd into L by U. This we have the correlation this n by n2 by n1, and this is the Piclet number. As the Piclet number increases, the correlation is like this. So, if you know this value, how much sterility, degree of sterility you want to maintain, then you can easily find out that what is the Damkohler number KdL by U. And if you know that at particular Piclet number, then you can easily find out the Kd value. And Kd value, as you know, it depends on temperature. You can easily calculate the temperature of sterilization. And this is the kind of schematic diagram of the continuous sterilization process, that this is the mixing tank, where we mix the media, it should be thoroughly mixed, and then we pass through this sterilization process. First the economizer, then we put it this section, then holding section, the heater is there, then we put it that heating section, then this is preheating the media, then cooler, and then ultimately comes to the fermenter. This is how it is operated in the industry. So, in this particular lecture, I try to give you how the medium sterilization is carried out in the fermentation industry, and which plays very important role. And we observe that continuous sterilization process appears to be the better as compared to batch sterilization process, particularly when we do it in a commercial scale. But another thing we observe that the sterilization with the help of filtration material filter is not recommended in case of low value products, but for high value products, typical cases where the media quality plays important role in the particular biochemical process, there we can think for it. Otherwise, most of the cases we use heat as a sterilizing media for the medium sterilization. And for continuous sterilization process, I mentioned that HTST technique is used. The reason is that at the high temperature, it is more effective to kill the microorganism rather than to lose the vitamin or quality of the media, because the exposure time will be very less. So, thank you very much.